So previously, you computed the standard deviation of all of the possible sample means. When you took all of the possible random samples of a size of 2 from that population of 4 scores, you then computed the standard deviation of those sample means and ended up with 1.58. That's called the standard error of the mean. It tells you the typical distance that the sample means are from the population mean. And that worked out just fine because you only had 16 sample means. But normally you're going to have populations that are much larger than 4, and you won't be able to compute by hand, the exact standard deviation of all of the possible sample means. So instead you need a formula for doing it that'll work with larger populations, so you don't have to have and compute every single sample mean. Okay? So our formula for computing the standard error of the mean is the standard deviation of the population divided by the square root of n. Okay? So you had previously figured out that the standard deviation of those 4 scores in the population was equal to 2.24. And then you divide that by the size of the samples that you're taking. So all of the samples that we're working with have a size of 2. So if you just take the population standard deviation divided by the square root of n, you get 1.58. which is the standard error of the mean. Again, the typical distance that the sample means are from the population mean. Okay. So anytime you have a population of scores and you know the standard deviation of that population, you can compute the standard error of the mean by just taking that standard deviation and dividing it by the square root of n. So you don't need to go through the mechanics that you went through in the previous problem where you actually manually figured out every mean in order to do this.